So we are here at the Space Access Conference in Phoenix, Arizona with Gary Hudson. Thank you very much for sitting down with us today.
My pleasure.
So today you had a presentation talking about the Space Studies Institute and very new, exciting proposal that you guys have. First of all, how did you first get started with the Space Studies Institute?
Well, I knew Jerry O'Neill back in the 70s, the late 70s, and certainly paid a great deal of attention to his work at the time. And then over the years, I unfortunately kind of lost touch as I was working in the commercial launch business, which didn't really touch on the subject of space settlement and satellite solar power and so forth. And then very recently, last year, I was asked to consider becoming president of SSI. And since the organization has only had 3 presidents, me being number 3, Jerry being number 1, and Freeman Dyson, the noted physicist and author, being number 2, I could hardly refuse.
So the project that you guys were talking about, well, that you presented in your talk today, was having a new private commercial space station that would be able to have centrifuges and have artificial gravity in order to prove out the concepts of being able to have space settlements so that we can have up to 1G. Can you touch more on that?
Well, basically the problem is that we have a few hundred data points at microgravity, at 0G, of people surviving 3 months, 6 months, up to a year. We pretty strongly expect that you can't go more than a few years in microgravity without very, very severe, probably terminal health effects. We have billions and billions of data points at 1G here on Earth. And we essentially have nothing whatsoever between microgravity and 1G except for about 15 days of stay on the lunar surface, man days of stay on the lunar surface. So before we start talking about retiring on Mars, as Elon Musk, founder of SpaceX, has said he wants to do, or living on the moon, we really need to understand, can you do that in anything more than just a transitory 3-month stay, 6-month stay, maybe 3-year stay or something like that? Can you have a baby? Can a child be born naturally and raised in that lower G environment once, if successful in a lower G environment, can they return to Earth? These are complete unknowns. We don't have any good models that tell us how this is going to turn out. And consequently, we feel that before we make a decision about rotating space settlements in free space, or lunar settlements, or Martian settlements, or wherever else we may go, even to other star systems ultimately someday, we have to answer this question.
So how do you propose to answer that question?
Well, many years ago, research scientists in the United States came up with the notion of using a centrifuge in Earth orbit. And the idea is that you would have a small-scale centrifuge for rats and mice. This centrifuge might be 8 or 10 feet in diameter, spin 10, 20, 30 RPM maximum, and you could dial in the rotation rate, and thus you could dial in the effective G that these small animals feel. It's a little bit like the space station in 2001: A Space Odyssey, but reduced to a much smaller size. We would take that facility, that experiment, and we would run it in at least two fashions. One is at, say, Martian gravity or at lunar gravity, and the other is at a full 1G. You might ask, why do it at 1G in space when we have the 1G data points on Earth? And the reason is pretty straightforward scientifically, that is, you want to control for that group of animals so that they experience exactly the same stresses from radiation, from flying through the Earth's magnetic field many times, a day as you go around the Earth every 90 minutes. The stresses of launch, just the stresses of being handled in the cages and so forth, but with the only variable being the G force that they experience. And so that's why you need 2.
So what kind of experiments would you be performing in order to find out whether or not these animals could reproduce in space and have productive children?
Well, the experiments are actually, in one respect, extremely simple. You're simply going to have a colony, a breeding colony, and you're just going to see what happens to them. You know, do they have stress? Are they born naturally? Is there stress associated with being born, and so forth? Now, the scientific community will have a whole battery of microbiological tests, biochemical tests, and so forth that they'll wish to conduct, and I'm not qualified to answer that detail, all those details. Our scientific advisory team will be responsible for crafting the experiments, but hundreds of thousands of words have already been written on these subjects. The scientific community knows what they want to do. The issue is they don't have any place to do it. And so the goal of SSI is to provide that place for them to conduct these experiments.